So I'd like to begin with Ron. I read an article that talked about the fact that you grew up in an adobe house built by your great-grandfather in the San Luis Valley of Colorado. And I also know that there's this early resource called earthandarchitecture.org, and I believe that was founded by you maybe in 2003, so 17 years ago. So there's this deep, knowledge about earth as a material, and I'm wondering, what are the roots for you? Where does this come from, this quest for earth as a material?
Well, in my own personal history, it comes from having lived in buildings made of earth, and not only in my lifetime, but my family has lived in buildings made of earth for perhaps time immemorial, whether you trace my European lineage to southern Spain, or you trace my indigenous ancestry here in the pueblos of New Mexico. And so I have that very deep connection to earth, but I also think that all humans have that deep connection to living in buildings made of earth, and they may have been disconnected from it in their recent histories, in their recent family histories, but for 10,000 years, humans have lived primarily in buildings constructed of earth in every continent on the planet, except for one, of course, which is too cold. But I think that we all as humans not only have this deep historical connection to earth, but I think we also have a biological connection to earth, in that we, like some other animals on the planet, have evolved to make those buildings made of earth. So, which means that our own physical makeup has allowed us to construct those kinds of buildings that way. We have the ability to grasp mud and to shape mud, and ceramics have been some of the earliest technologies that we as humans have developed. And so I think that our connection goes beyond just a connection of memory, but it goes to a connection of biology, a connection of genetics, a connection of geology.
Right. So it's in our DNA.
I believe so. In many ways, I mean, if we look at what creates the fundamental proteins for the creation of life, it comes from molecules that are associated with clay.
Interesting.
So we think sometimes about that as a kind of biblical story, right? That people come from dust to dust, but it's also it's a scientific truth that you can create the foundations of life by combining certain molecules of clay, the fundamental proteins and amino acids.
Yeah. I think one of the things that really interests me about the architecture that the two of you do in your practice together is an exploration of materials that are not necessarily typical for structures: salt, sugar, coffee grounds, earth maybe being one of those, or dirt. But I want to kind of move to emerging objects for just a moment. And I believe there was a Smithsonian article that came out that talked about the 40 things that you need to know in the next 40 years. And one of those things was the quote that sophisticated buildings would be made of mud. And so I wonder if we could start from that place. What sparked your interest in that comment, and what did that prompt in terms of emerging objects?
Well, interestingly, one of the first materials that we tested in our BinderJet 3D printer was clay. It was a ball clay. If we go way back to, I think, 2010, and we were experimenting with recipes for printing with clay that were open source that we had found online. And we tested ball clays and porcelains. And then we were invited to participate in the Biennale of the Americas, which was in Denver. And we decided to 3D print with sand. So in order to do that, we had to hack our printer and experiment with different sand formulations. We experimented with eventually adding a cement to the matrix that we were printing with. And as we were printing for that exhibit, we we were printing objects that fit in the build bed of the printer, which is 8 inches by 8 inches by 10 inches. And we were laying them out, and we realized, oh, everything's the same size. So we started printing parts that we could aggregate together to make a whole. So suddenly we realized, oh, we can stack parts and make something tall or something long. And then we started stacking in both directions and realized, oh, we don't have to just make models. We can actually make buildings through this technology. We can make building blocks of the future, and we can make them out of sand. We can make them out of cement. We could make them out of clay, Chardonnay, etc. So that's a little bit of the origin story for us. And I think when we read that quote, we realized that we were kind of on the cusp of thinking about how we might build for the future using this nascent technology with these really old traditional materials that have proven themselves over time. You know, the earth and construction has this flywheel effect of keeping buildings warm in the interior in the winter and cool in the summer in arid environments. And we can capitalize on just the inherent quality of the material itself.
One thing about that Smithsonian article that predicted that sophisticated buildings of the future will be made of earth is that I always found it interesting that I thought that sophisticated buildings of the last 10,000 years were also constructed of earth, and that inherent to earth is construction is a sophistication, and we as humankind have been developing that material for thousands of years, and so it's the material that we've been working on the longest. It's fundamentally the most sophisticated material that we have under our control as builders of the environment.
And so because we've had such a long time with this material, what does that allow us to do? How do we understand it better because we've been working with it? Or do we? Maybe we left it behind for some time.
Well, you know, I think increasingly we're leaving it behind, and it's unfortunate. So fewer and fewer people around the world are living in buildings made of earth because they're moving towards other building materials that are extremely resource intensive, concrete, for example. And I think what we have not been able to do with earth is to bring it into a capitalistic economy. So no one can really make money building buildings made out of earth, but certainly building buildings made out of concrete or steel, those are materials that have capitalistic power, and earth does not. And so it's almost like the material has resisted itself bringing itself into the economy. And so I think given the global crises that we are in, it's an opportunity for us to look back at this sophisticated technology that we have developed and begin to use it in our capacity to create elegant buildings, to create housing for those who need housing. There are examples of almost every architectural typology made of earth around the world. There are airports made out of earth in Yemen, for example. There are museums, embassies. And so I think it's a building material that we should not forget.
And I know you authored a book about earth architecture in 2008 or 2009, so we'll include a link to that as well. So you've done a lot of studies around what's been built with earth.
Right. We both have a really nice opportunity to travel around the world and look at buildings constructed of earth and to see the diversity of earth and construction around the world and the many different kinds of techniques that are available to use only fundamentally earth and humidity, maybe sometimes mixed with some organic material to make shelter.
So I think in looking at the structures that you've built using a 3D printer, you described this printer as old technology, but in the photograph it looks almost robotic. There's this long arm that is filling earth into sections or into structures. And I wonder if you could talk about what the use of new technology does. You started to comment about how it might change economy or the access to building with earth, but what is this merging of new technology with the old material? What does it allow in your views?
Well, we are using a robotic arm to 3D print with the Earth. And I think it does a couple of things. It allows us to build more quickly than we might be able to by hand, right? So we can design something in the computer, and then the robot is able to, well, we have a continuous hopper that pumps the Earth up to the robot, and the robot puts it in place. So we can make complex structures. We can work more quickly. I think, for someone like me, I might not be able to lift a 40 or a 50-pound Adobe over my head and stack it, but the robot can build higher than I am tall, right? So I think the limitations that might traditionally be there are negated by using the robotic arm.
I mean, what we're discovering, which is really interesting, and it was our theory that's proving to be true, is that we could create a printer that's smaller than the object that we're creating, and so we can print a very large object. And also, right now there are primarily just 2 people at a time on the building site, and the tasks are to sift mud, to sift dirt, to mix to make mud, and to press the button on the printer. And so if you think about that as well, there are times when only one person could actually execute this job to construct a very large structure. So these are the largest structures that we've made this summer, and they are 12 feet tall, and they are large as a small room. So they're really occupiable, and 2 people could sleep in one of the rooms that this printer can make. And the printer itself is very lightweight. And so I think one of the things this process does is allow for someone with very little skill in robotics, for example, or computer modeling or construction to actually participate in the making of a building. Now, having said that, that is not necessarily novel. Again, for thousands of years, just a couple of people using mud have made buildings with their own hands. But I think what this also does, it allows for the deposition of mud to occur in ways that might not be so easy to do by hand. And that's pretty exciting. And I think while this research is fairly new to us, we're discovering that we can make stairs, we can make insulated wall cavities, we can make surfaces that have micro shading, we can make structures that are very thin but very strong. We can use less material. So I mean, this is research that's just beginning over the last couple of years, printing these very large structures, but I can see years and years of continued research on what's possible using this method.
One thing that, we're, as Ron said, we're at the very beginning. One thing that I really like about this traditional Adobe house that is in Ron's family is that the interior of each room is plastered with a different color earth. And I love that. I think it's so beautiful. And I love the notion that we might be able to 3D print with different color earths to get different effects on the interior. Or, for example, we've been digging wild clays in the mountains of northern New Mexico, and the clay has mica in it. So we could have that kind of shimmer, right, or reflectivity in the material. And so we're just at the cusp of thinking about the expanse of materials that we could print with and how they might transform this process as well, or affect the process. So
yeah, this really opens up the possibilities. It's very fascinating.
Yeah.
I'd love to end with just a question about, I know we were supposed to talk about the basics of mud construction, and we have been essentially talking about that, but I'd like to ask about, if we think about rammed earth or mud or adobe structures, a lot of times they are assumed to be designed with fewer means. If we have less means, we design in that material. And so I'm interested in the social dynamics of mud and what that means. How are you confronting that perception in a different way, if you feel that you are?
Oh, yeah. Earth has a long history of being considered a material for the poor. And that has flipped occasionally. And so the history of earthen construction in New Mexico and southern Colorado is actually that there became a point in time when building codes made it prohibitive for someone who was poor to build the houses they had built for centuries for different reasons, right? The code might have said, well, now you need a foundation that goes below the frost line. And walls of adobe can be 2 feet thick. So imagine now you have to build a concrete foundation 2 feet thick that goes 6 feet deep. And you also need a bond beam above the wall to stabilize it, when traditionally you would have used small pieces of wood to stabilize the wall from lateral forces. So at that same time that the poor could no longer build the buildings made out of earth, the wealthy began, especially in Santa Fe and other cities in New Mexico, they began desiring these buildings made out of earth because of their romantic connotations and historical connotations. And so there are grand, homes in New Mexico made out of adobe. And there's actually, I mean, given what I said about earth not entering the realm of capitalism, there is the largest adobe yard in the world in New Mexico that produces up to 25,000 adobes a day for sale around the world.
Wow.
And so there are these preconceptions about wealth and poverty that have also affected and impacted the populations who would build these buildings traditionally. So, back to your question, which was how are we dealing with this phenomena of the preconceptions of earth being a building material for the poor? I think this largely has to do with design and the elegance of the production of a building. And so, people travel all around the world to see the wondrous structures that have been built over the centuries made out of earth. And in some cases, we're finding these are major tourist sites where people pay a lot of money to stay in the hotels. And so if we can design with elegance, but also with a certain degree of, maybe the word might be that it could be both inexpensive and beautiful, then I think we can tread into the realms where it could be more culturally acceptable again.
Yeah.
Yeah.
We call this project Mud Frontiers because, of course, we've been printing at the frontier between the United States and Mexico, and we're also at a technological frontier. But we also think of it as connecting to mobility because the printer is so lightweight, ubiquity because soil is everywhere, right? And democracy because we're developing this software app called Potterware, which runs in the cloud, which means that anyone can develop files for 3D printing. You don't have to know how to model anything. So it's immediate, like an 8th grader can do this in a day.
Right. There's also a real special connection to the actual place because the soil comes from the local area. So different structures will have different colors and tendencies, I imagine, based on where they're built.
Right.
Exactly.
Yeah.
Exactly.
Yeah. Well, I want to thank you so much for this wonderful conversation about mud and construction. And I really applaud the research that you've been doing, and we'll look forward to following it as it continues. And thanks so much for your time.
Yeah, thank you.
Thank you.